Hey everyone, in this video we're going to be looking at how we can find the distance between 2 points located on a graph. In this example you will see that we have the points here and here that are located at the positions 3, 6, and also the position -2, -6. Now for our purposes here, let's refer to this as maybe point A and this as maybe point B, just for reference. Okay, so when we're doing this, one thing we want to think about is you can't just measure distance by counting as you can when it's perfectly horizontal or perfectly vertical. If you have 2 points that are perfectly horizontal, so for example, let's suppose we have a point at 2, 0 and another point at 6, 0, then it's really easy to find that distance. You can simply count 1, 2, 3. I'm sorry, I messed up the scale there. Let's back that up a little bit. So if I'm looking at my scale, then you will see that this is 4, here's 2, so 3 is right in the middle, 4, 5 is in the middle. So if you're counting, we could go 1, 2, 3, 4. So there is a distance of 4 units between 2 and 6. That works fine if we're perfectly horizontal or perfectly vertical. However, whenever we have points that are not horizontal or vertical, we can't do that. We can't just count because now we're moving on this angle in terms of our distance. So to figure out the distance between points that are on an angle like this, we have another method, and that is going to be our distance formula, is one approach to this. So using our distance formula, it will calculate the distance between these 2 points. It's actually quite easy. So you'll notice if you examine the distance formula, it tells us that the distance formula is the square root of the sum of the squares of the difference of our x values and y values. Now that was a lot of saying that and explaining that. So let's simplify it. Basically all we're going to do is calculate the difference in x values, difference in y values, then square those, combine them together, and then we will square root that. Now again, that still sounds like could be a little bit complicated, so let's actually see this in action one time. So to calculate my distance formula, I need to figure out what is the difference in the x values and the y values. So when it says x2 and x1, that simply refers to the x value of point 2 and the x value of point 1. Now, which of our points over here, A or B, which one is point 2 and which one is point 1, really doesn't matter. So I could choose A to be point number 1. I could choose B to be point number 2. I could have done it the other way, it doesn't really matter. So whenever I'm looking at x2, that's say what is the x value of your second point. So in this case, my second point is here. The x value is -2. And then I'm going to subtract the x value of the first point, which is 3. So I'll be doing -2 minus 3, and then we'll square that. Let's come and do the y values. Y value of the second point is -6. Subtract y value of the first point is +6. So we have our values in, and at this point it's just a matter of combining terms, combining numbers and simplifying. So -2 minus 3 would be -5. And if we square that, and then -6 minus 6 will be a -12, and again we will square that, and let's not forget about our square root. Then after that I will again simplify. -5 squared is 25, plus -12 squared is a +144. Then if we combine these together, we should see that it combines to 169. Now fortunately 169 has a good square root. If you're not aware of that, you could break this down through a process like a factor tree, but I do know that square root of 169 is nice and comes out to be just simply 13. So that means that the distance between these 2 points is 13, and that's it. Now I do want to show you a quick other way that you could approach this, because the distance formula can look a little bit involved. It's not really. But the distance formula is really just another take on Pythagorean theorem that a lot of people have learned in earlier grades. And I'm going to leave this process here just so we can kind of see that as a reference point in just a second. But if I go back to my graph, this time what I'm going to do is actually, let's look at what would happen if I was to try to figure this out, the distance between these points using Pythagorean theorem. Well, to do that, Pythagorean theorem, as you know, relies on, or it works with triangles, and specifically right triangles. So I need to construct, can't spell here for a second. So I need to turn my graph into a right triangle. I can do that by going from my upper point, dropping a line straight down, bringing this over, and then if I connect my points here, you'll see that I construct a right triangle. So in this situation, remember that Pythagorean theorem is set up where it's a squared plus b squared equals c squared. And the only thing that really matters here is making sure that the c value is your hypotenuse, or your longest side. Also, that would be the side that's across from the right angle. So with my right angle being here, this other side is the hypotenuse. The vertical and horizontal side could be A or B, it really doesn't matter. So if I choose to let this side be A and let this side be B, and of course this side has to be C. So based off of that, the length of side A, I could count, since that's a vertical distance, that's a vertical line, so you can count that one. So you'll notice that it is 6 units up here, and it's also 6 units down. So this side has a length of 12. That would be my A value. My B value is the distance here. And that distance would be from 3 over to -2, which is a distance of 5. And we're trying to find c squared. So notice what happens. 12 squared is 144 plus 25 for 5 squared equals c squared. Now you should notice some similarities at this point between what we just did over on the distance formula side and now where we're at with Pythagorean theorem. So you'll notice at this point, look, we're starting to copy this. Now I want to figure out what the c value is. Currently it's set up as c squared. But I want to know what is just simply c. So that means that this square must be dealt with. It must be removed. So the way we undo squaring, the inverse operation of that is to square root. So if I square root both sides at this point, then you will start to see that this is exactly like what we just did. So the square root and the square would cancel, leaving me with c is equal to the square root of 144 plus 25. Again, that is now identical to what we just did in the previous step, and we know that's going to become the square root of 169, which is 13. So therefore, c again is 13. And that's how you do the distance formula. So you see the distance formula version, you see Pythagorean theorem version. Both of these can be used to find the distance between 2 points in any setup, whether it's perfectly horizontal, perfectly vertical, or on an angle, which is the specific case when you would want to do distance formula. Hope that helps. Take care.